In the first module of this course, I'm going to introduce the basic properties of semiconductor materials. I'll go from the structure of an atom to the energy band representations when they are arranged into a solid crystal. With the band diagram, I will then explain the physical distinctions among conductors, insulators, and semiconductors. Finally, I will describe electrons and holes as charge carriers in a semiconductor and how they move around in a piece of solid. I believe you all know the structure of an atom, which consists of a positively charged nucleus surrounded by negative charged electrons. The distance between electrons and the nucleus are arranged into distinct orbits. This model is not completely correct, but it's easy to understand and visualize. You may imagine that it is just like satellites orbiting around Earth. For the ease of drawing, the 3D structure of an atom is usually drawn with a 2D representation in many textbooks. In this picture, the electrons located at the orbit closest to the nucleus have the lowest energy, and the electron's energy increases and is getting further away from the nucleus. It is similar to the potential energy in mechanics that higher elevation correspond to higher potential energy. There are two important properties of these orbits. First of all, the orbits are distinct energy levels and no electron can stay in between. Secondly, each orbit can only hold up to a fixed number of electrons, typically 8. In an atom, the total number of negatively charged electrons is equal to the total number of positively charged protons in the nucleus, making an atom electrically neutral. The placement of electrons starts from the lowest level and then the next lowest level with spaces available until the electrons are all placed. Based on the number of electrons, atoms of different elements are arranged into a periodic table. The row number in the table represents the number of orbits in the atoms. Atoms of elements in the same column usually have the same number of electrons in the outermost orbit. And the focus of this course is mainly on atoms of elements in the fourth column of the table. In particular, we will mainly study the silicon crystal, which is the most popular semiconductor used. But the same knowledge can be easily applied to other semiconductor materials such as germanium and gallium arsenide.